questions 21 through 25 on the 2008 grade 9 Pascal math contest. If P is between 3 and 10 and Q is between 12 and 21, then the difference between the largest and smallest possible values of P over Q is. The largest value of P over Q will be when P is the largest, and therefore that's got to be 10, since the interval is between 3 and 10. But when Q is the smallest, right? If you make the denominator as small as possible, the overall number will be large as possible. The smallest possible value of Q in that range is 12. So there you go. That's the largest. The smallest P over Q will be, well, for P, it's got to be the smallest number. And in this range, it's 3. And for Q, we have to choose the largest, right? We've got to make the denominator as large as possible. So the largest number in that range is 21. So this is the largest and the smallest. So we have to take the difference, okay? The difference just means subtracting these like that. And we got to do, the hardest part about this question, in my opinion, is getting this into lowest terms. So let's see here, 21, 21, 12, and 12. So this becomes 210 minus 36, right? All over, I'm going to break this up into prime factors, 3 times 7, and then 2, 2, and 3. This will help me. This is going to be 174, all over 3, 7, 2, 2, 3. Those are prime factors. So 174, I believe, is 2 times 3 times 29. And that's over 3 times 7 times 2 times 2 times 3. These guys cancel, and we are left with 29 over 42. So there you go. 21 is 29 over 42, which is choice A. Ginger walks at 4 kilometers per hour and runs at 6 kilometers per hour. She saves 3 3/4 minutes by running instead of walking from her home to her school. What is the distance in kilometers from her home to her school? We use the standard formula, speed is equal to distance over time, right? And when she walks, the distance is going to be speed times time. So her speed is 4 kilometers per hour. And the time, well, we don't know the time yet, so we'll just put T for time. When she runs, the distance is the same, but the speed is now 6 kilometers per hour. And the time we don't know, but we do know this important piece of information, that is 3 3/4 minutes faster. So we subtract 3 3/4 minutes, so that's 3.75. But that's minutes. And this speed is in kilometers per hour. So I have to convert this minutes to hours and divide it by 60. That's how you do that. So there you go. We got our 2 equations. This is equal to D, and this is equal to D. So I can set those equal to each other. So that means 4T is equal to 6 times T minus 3.75 over 60, like that. All right. So here we go. Let's solve for this. 4T is equal to 6T minus 22.5 over 60. So 22.5 over 60 is equal to 2T. And looks like T is going to be 0.1875. All right. So what do they want us to figure out? The distance. Okay. Distance is equal to speed times time. And we can use either of those. I'll just use the simpler one, which is 4T. And T we just got as 0.1875. And therefore, that is 0.75. And that's in kilometers. And 0.75 in terms of a fraction is 3 over 4. So 22, the answer is E. Four pieces of lumber are placed in parallel positions as shown, perpendicular to line M. piece W is 5 meters long. Piece X is 3 meters long, and its left end is 3 meters from line M. Piece Y is 5 meters long, and it is 2 meters from line M. And piece Z is 4 meters long, and it is 1.5 meters from line M. A single cut perpendicular to the pieces of lumber is made along the dotted line L. The total length of the lumber on each side of L is the same. What is the length in meters of the part of piece W to the left of the cut? So, first thing we'll do is start labeling this. This whole thing they're saying is 5, but I'm going to label the part that's left to the cut X, because that's what they want us to find. Essentially, that question just boils down to find X. Well, that means that to that is X, so that means this part here that is right of that dashed or dotted line has got to be 5 minus X. Okay, so here we go. This whole thing is X, but we know that from here to here is 3. So this part has got to be X minus 3. Okay, so here we go, same story. This whole thing is X, but from here to here is 2. So this part has got to be X minus 2. And then from here to here is X. This is 1.5. So from here to here has to be X minus 1.5. All right. Now we get to the other side. Well, this part we already labeled 5 minus X, so that's done. This, well, the whole thing is 3. And this part is X minus 3. So this part has got to be 3 minus X minus 3. So it becomes 3 minus X plus 3. And that is 6 minus X. Okay, so I hope you understand how I did that. This whole thing is 5, as they tell us. From there to there is X minus 2. So from here to here has to be 5 minus X minus 2. So it becomes X plus 2, which is 7 minus X. Right? And in a very similar way, that whole thing is 4. From there to there is X minus 1.5. So therefore that part has got to be 4 minus X minus 1.5. But if you take it out of the brackets, it becomes 1.5 like this. And that is, of course, 5.5 minus X. So that's the setup of the question. Now this piece of information is very important, obviously. It tells us that what's on the right side is equal to what's on the left side. So what is on the right side? We got these 4 guys, so let's add them up. We have X plus X minus 3 plus X minus 2 plus X minus 1.5. And that is equal to what's on the other side, the right side. On the right side we have this, 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 and this. So let's add those up. 5 minus X plus 6 minus X plus 7 minus X plus 5.5 minus X. All right, now it becomes just straight algebra. Adding this, we get 4X minus 6.5. And on this side, we get 23.5 minus 4X. Bringing it over, 8X is equal to 30, and therefore X is equal to 30 over 8. And 30 over 8 is 3.75. So there you go. That's what they wanted. 3.75 is what they wanted. Find X. So number 23, the answer is D. Five circles are drawn on a piece of paper and connected as shown. Each circle must be colored red, blue, or green. 2 circles connected by a straight line may not be colored the same. How many different ways are there to color the circles? All right, how shall we approach this question? what I'm going to do is by concentrating on just the first circle right there. I'll call that the first circle. So first circle. And the first circle can be either red, obviously, green, or blue, right? And then what we'll do is we'll look at each scenario. So if the first color is red, that means we can have the next color to be green, right? This guy right here. And similarly, I can have red, and then I guess I can put blue, but I'll do that down here. Okay. Now let's see. I can't have any other choices, right? I can't do red, red, because we have this rule that two circles connected by the same line cannot be the same. Okay, so red, green, red, blue is the only thing I can do. But let's move forward to the next one to see what happens. If it's red, green, then the next one has to be blue, right? Or it could be red, green, and red. That's perfectly fine also. Okay? If it's red, green, and blue, this guy, then what about this one here? What color can that be? Well, that has to be green. It can't be red or blue. If it's red, green, and red, I've got two choices. I could put blue, but I also could have red, green, red, and green. Okay? So this is the setup. These three are the only ways you can do it if the first is red and the second is green. Okay? We're done labeling this part. Now we have to worry about this guy at the very end. This guy at the very end, for that, there's two choices, either red or green. This one, there's two choices, either blue or green. And this one, there's two choices, either green or blue. So as you can see, we've got 1, 2, 3, 4, 5, 6 possible ways of arranging red and green, if those are the first two. All right? So I hope that makes sense. Let's do it once more. And if it's red and blue, the next guy here, the third one, can be, let's say, G, green. Correct? But if I have red and blue as my first two, I can also put this as red. Correct? Okay, so far so good. Now we've got to concentrate on this guy, which is this guy over here. That letter, if it's RBG like that, that one has to be B. There's no other choice. But if it's RBR like this, that can be B. But I could also put RBR and a G. That also works. Now I've got to concentrate on this final guy. And for G, it could be either R or B. For R, it can be either G or B. And for R, again, it can be either G or B. So for the scenario where the first two are R and B, again, you get 6. Okay? So I'll just do one more because I think you're getting the hang of this. Let's do G's now. G as my first letter. The next letter has to be either B or it has to be either R, right? It can't be GG. All right. If the next letter is B, then what goes here? Well, it's got to be either R or a G. So GB has got to be followed by either an R or a G. So there you go. If this is GBR, what goes here? Well, there's only one possibility. It's got to be a B. If it's GBG, then what goes here? Well, it can be B, but it can also be GBGR. That would work also. Does that make sense? I hope. Trying to do this slowly. For some of you, this is painful because you already figured it out. But for those who have not, I'm just trying to explain it slowly. And then now we got to figure this out. So for R, it can be either B or G. For G, it can be either R or B. And for G here, it's going to be either R or B. So if the first two letters are GB, again, you have 6 possible choices. And in a very similar way, when you do GR, you'll get 6. And for the B's, in a very similar way, when you do BRs, you'll get 6. And when you do BGs, you'll get 6. Okay? And when you add up all these, you get 6 times 6, which is 36 possible ways of arranging these circles with the colors. So 24, the answer is D. In the diagram, PQR is right-angled at P and has PQ equal to 2 and PR equal to 2 root 3. Altitude PL intersects median RM at F. What is the length of PF? So they want you to find this length eventually. Let's begin. PQ, they tell me, is 2, and PR, they tell me, is 2 root 3. So very quickly, using Pythagoras, I can figure out RQ, right? So RQ squared is equal to 2 root 3 all squared plus 2 squared, like that. So this is 2 times 3, which is 12, plus 4. So 16 is RQ squared, and therefore RQ is equal to 4. So label that right there, 4. And next we can figure out the length of PL, this whole distance right there. How? Well, the area of the triangle, the big one, the whole thing, PQR, can be calculated in a couple ways. The first is by using this as the height and this as the base. And the second is by using that as the height and that as the base. And both of those, of course, will be equal to each other since they both represent the area. So the area will be 1/2 base, PQ, times height, PR, and that will be equal to 1/2 base times height, RQ, times PL. So the halves cancel. PQ is 2, PR is 2 root 3. RQ, we just figured out, was 4, and then we just have PL left. So solving for this, PL is equal to root 3. Okay, so those are the first two findings in our question. Now, where do we proceed at this point? Now the question gets a little bit challenging, right? The first couple of things were pretty straightforward. What I want to find at this point is the length of RL from here to here. That's going to help me. So how do I do that? Well, we do that by understanding that we've got some similar triangles here. The similar triangles are the triangles RLP and PQR. Why? Well, because they share all the same angles, right? Because this is a right angle, and this angle is common to both. So therefore, the third angle in each of those has got to be the same. So if those two triangles are similar, which they are, the ratio of the sides will be similar. So RL over PL is going to be equal to PR over PQ. All right? So that means RL over PL, which is root 3, we just figured that out, is PR, which we know is 2 root 3. They've given that in the question. Over PQ, which is 2. They've also given that in the question. Solving for this, and we get RL is equal to 3. All right? So I'll just put that in here. I'm getting a collection of values. Well, we know that RQ is equal to 4. Well, if RQ is equal to 4 and RL is equal to 3, that means LQ must be 1, correct? That's just simple subtraction. So there you go. I got another one. Now where do we want to proceed? So far we're doing pretty good here. We want to go with another similar triangle situation, but this one is not as obvious, and this is, in my opinion, the harder part of the question. We've got to connect M to this side, and we've got to do it in a way that it's parallel to FL, so that this is a right angle. All right, so that's, I think, the key to the question here that allows you to sort of figure this out. And if you do that, you get a relationship between two triangles that are similar. And those two triangles are PLQ and triangle MXQ, right? PLQ is this guy right here, and MXQ is right here. And I'm labeling this X right there, that point that I just drew the line to. And therefore, the ratio of the sides will be the same. So I've got MQ over XQ is equal to PQ over LQ. Okay? And let's see here, MQ. Do we know any of these? Yeah, MQ we know is 1, because remember they told you that this is the median. So if PQ was 2 and M was the median, then M to Q is 1. So we got 1 here. XQ, well, XQ we don't know yet. All right? And PQ is 2, and LQ we don't know. Well, actually, LQ we do know. Sorry, it's 1. All right, I was getting worried there. Okay, so XQ, that means we can solve, and if we do, we get a half. Okay, perfect. So we continue with our collection of distances. Eventually, the distance that we really need is FL. Once we get FL, we just subtract it from PL, and that gives us our FP or PF. All right, we're almost done. We have to now figure out MX. We got XQ, we have to now figure out MX. MX is this distance right here. Okay, that's pretty straightforward. That's, again, a similar triangle. MX over XQ is equal to PL over LQ. Same sort of similar triangles, ratios. So MX, XQ, we just got a half. PL is root 3. LQ is 1. So that means MX is equal to root 3 over 2. All right. We are continuing with our collection of data. And I think the only thing left at this point is just figuring out this distance right here, RX. RX, well, let's see. R to Q all the way down was 4, right? So RQ was 4. And then we just figured out that XQ is a half. So that means RX, this distance from R to X, will be 4 minus a half, which is 7 over 2. Okay? So we are one final similar triangle relationship away from figuring out FL, and then once we have FL, we can figure out PF by subtracting it from PL. And that final similar triangle relationship is as follows. It is these two triangles, RLF and RXM, right there. So we have RLF right here and RXM, this guy right here that involves X. Not all the way down to Q, but just to X. Those are similar. And therefore FL over RL is equal to MX over RX. And I believe we know all of these except FL. So FL over RL, which is, let's see here, 3. MX is root 3 over 2. And RX is 7 over 2. So solving, we get FL is equal to 3 root 3 over 7. All right. We are almost done. I think I can do it on this page. The final step, of course, is that PF, which is what they want us to figure out, is equal to PL minus FL. PL is root 3. FL I just got over here, 3 root 3 over 7. I can get a common fraction, 7 over 7, and if I do, that becomes 4 root 3 over 7. There you go. 4 root 3 over 7 is the answer to number 25, which is choice C.